Hello and welcome to the Thoughtful Software Podcast. My name is Fahad Chokat and my co-host is Andrew Wolf, CEO of Skiplist. So we believe thoughtful people and thoughtful software will change the world for the better. And this podcast is all about diving into new technology, discussing industry trends, but more importantly, we want to help people be better at what they do. And this is the focus of what we call thoughtful software. So in this episode, we spoke with Kyle Reissner, Head of Digital Customer Experience at Rockwell Automation. And Kyle has more than 20 years of diverse industrial product management and marketing experience. And in Kyle's current role, he is responsible for defining and executing an enterprise strategy to drive a digital experience for customers that is connective, intuitive, and personalized across the full lifecycle. And it was a really fun conversation. We spoke about industrial automation and the impacts and consequences of automation. We touch on what is smart manufacturing and the future of automation. So we hope you enjoy. Here is Kyle kicking it off. Here we go.
Well, thanks for having me, guys. I think one of the things that I'm here at Rockwell and Rockwell Automation as a company. About a year and a half ago, we took a really serious look at our digital experiences across for our customers. And in that sort of serious look, it was decided that we invested more money and more bodies and more people and more attention to the whole life cycle of the digital experience for our customers. And that's when I joined the group as a customer experience leader. So I'm responsible for research, design, and on our unauthenticated web experiences. And we expanded the group to have many other leaders that had more different functional roles, like omni-channel e-commerce, like our distributor engagements of how we go to market, our platforms and technologies to really scale our focus on this. So that's what I do at Rockwell. And then I've been in that role, about a year and a half now, and we've expanded the team to have more focus on the overall life cycle and digital engagement with our customers, and that's primarily sitting on the pre-sales and discovery side of our products. But it's more and more as we look at the threads of where our customers' expectations is really, it's a thread about discovering our products, configuration of products, pricing, procurement, and then design, implementation, and maintain. And they don't look at it like it's just one piece that they want a good digital experience for. They want the whole life cycle. And that's what our digital transformation team is starting to look at more and more. And that's part of really why customer experience is the center point of our efforts. So that's what I do at Rockwell. My background, I spent 20 years in industrial automation, in and around industrial automation. I spent the first 10 years of my career in project deployments on plant floors, really dirty, remote places around the world. And in that 10 years, I worked for an engineering firm. I worked for a software startup that focused in on analytics before analytics was a thing, circa 2002 to 2007, and got to really see applications and really more of the complexities of deployment. So from there, I jumped into a large, Fortune 100 company, and spent a ton of my time learning marketing and product management and leadership elements. And then I moved into Rockwell about 5 years ago and spearheaded the development of a new platform that was really to prove or disprove, a lot of ways we can say, that mobile and apps, what mobile and apps would look like in industrial applications. So that's sort of how I jumped up and jumped around and landed here. So that's a long-winded intro, but to give you a little background.
Yeah. So I'm going to hit with the first question here, and it's going to be kind of long-winded. So you're primarily a B2B company selling to manufacturers. So the digital experience for your customers, being able to buy your products, know about your products, learn about your products is important. So we'll take that, put that aside because I have questions on that later. but there are other people that are impacted by your services and products, primarily not your customers, the consumers. And we live in an age of corporate responsibility, and people are forcing corporations to take a stance on differing topics. And in your case, it would be automation. And what is the stance for automation? I believe automation's good, and I'm sure because you work at Rockwell, you believe the same thing. But have you guys thought about digital experience to help educate non-typical customers on automation? And what does that digital experience look like? And if you haven't, is it something that you might look into in the future?
Yeah, it's a good question, and I think it, I might go all philosophical here on automation in general. I mean, I've been in the industry for 20 years. We've seen, what's interesting is a lot of people at Rockwell, and what I've learned in my experience in the whole industry is that if you're not in the industry, you don't really get it, right? You don't understand the complexities. You don't see the tangential benefits of automation. From a person who's reading a paragraph about automation, usually the takeaway is it's bad for jobs, right? Mm-hmm. In a lot of cases, that it's not. That doesn't surprise me, right? You see. You look back in human history and you see, thousands of people, stitching clothing, and then seeing a loom machine be invented, and then all of a sudden we have, all those people don't have a job anymore, right? You don't see the elements of the design of the machines and the supporting of the machines, and how that frees up focus and time for societies to go do different stuff, like have an industrial revolution, right? Modernize stuff like that. But also, there's other tangential benefits around quality, safety, right? And that's where a lot of the benefit, in my opinion, lies for automation in general. So, does Rockwell Automation as a company spend a ton of time educating consumers or the public on the benefits of automation? I think the answer is no. I mean, we've recently rolled out a new brand campaign that's changed our sort of tagline from listen, think, solve, which is very much in engineering. People brought us problems to solve with automation. We listened about them, we thought about them, and then we solved them, right? We used a lot of electrical components to do that. Our new tagline is expanding human possibility. And I think that it's really 3 words that can drastically change the trajectory of where we focus on. We still are that engineering company. We still are a bunch of propeller heads essentially solving problems, right? Rockwell as a company doesn't spend a lot of money on marketing, and that's evidenced by the fact that our products just get a lot of attention and a lot of funding, right? In our business, you win if your product can hit 70 degrees C versus 60, okay? Mm-hmm. But the last 10 degrees C to support that, so that your product can be in the middle of the desert operating for 20 years, takes a boatload of engineering to do and a boatload of additional costs to do. So, imagine components in the bowels of a ship for the life cycle of an oil tanker, which is 30, 40 years. They're building that machine, and our products not only have to work for that life cycle, but have to work in that environment, and then we have to support it for that long, right? So when you think about it, these are not easy things to engineer and support. But a lot of people don't even know about A, who Rockwell Automation is, B, what the benefits of those things are. And I think in the last year, the company, particularly with our new CEO, Blake Moret, doing a lot more outward facing education on what it means to be, what automation really brings to society, right? I've not really seen our competitors do that well, or really sink a lot of time into it. And I think Rockwell as a company is moving towards that with this sort of new brand identity. And conversely, one of the things that my team is doing is looking at how we communicate on the web around that brand identity. And they're in brand awareness training today, because our new tagline is not just about a tagline, it's about a philosophical way of how we communicate. So you should see more and more of that. What's interesting is that Rockwell spends a ton of time supporting STEM, and we have Lego build competitions, like a lot of stuff that is more, left brain engineering side, engage with lots of engineering schools around the Midwest and US in general. And it's really about cultivating that awareness in the engineering realm. But again, that's a very select slice of people, and which, like it or not, that stereotype of people don't really go outwardly sharing too much about our industry, because just the nature of the way that those personalities are in the engineering side. So
I find this really interesting because if you think about it, you touched on it, just as a human society, like if you're somebody on the manufacturing floor that's moving a piece from one place to another, I really would ask that person to really think about, is this what humans are supposed to do, right? Let a machine do that work and you can go focus on something else that might be a little bit more interesting. And there's a lot of jobs like that we're not meant to just stamp an envelope and then pass it. It's really not a human thing. It's a machine effort.
Well, I mean, one thing that I learned when I did a stint at Honda for a couple of years in consulting, and they view their frontline workers, their assembly workers, as the most important people in their organization. The engineers and the planners and even the maintenance people, they're not as important as the person touching the product. In that case, it was a car plant, so touching the car, right? So much effort went into, when you think about one person putting on tires, there's a support staff of probably a 1 to 10 ratio of how to make that job more consistent, how to make that job more safe, how to make that job a better quality, and how to reduce the strain on that worker. Like the amount of money that I've seen, and really this, if you take this philosophy into all automotive manufacturing, the amount of money the companies spend on that particular job task is immense, and that in essence makes that person super important. One of the things I learned, I did another short consulting stint for about 3 months at Toyota. And one of the things I went through some lean training and some Six Sigma training over the course of my career too. And it's funny because even Elon Musk tweeted last year that too much automation can create problems. Okay, it creates too much complexity. And what Toyota believes is that there's a concept of making people's work useful. So actually taking out automation and putting quality checks into the process that are manual, because it gives that worker a sense of purpose, and that sense of purpose is translated into more passion for their job and essentially more loyalty. So there definitely is a level of too much automation. Again, I debate this with my family and my friends. All the time, whether automation is good or not. I would say ponder what you use every day and consider how it's manufactured. And the real question is could that thing even be manufactured without automation? And I think we're, in the 80s and 90s, you could argue, you can make stuff with your hands, make it manual. You're just going to make it slower. Well, consider this. I got to sit with a bunch of research scientists at a company that made tape, okay? And they pride themselves on the fact that they can make tape for any application, and the glue is perfect and the consistency perfect, but also when you tear the tape, it tears perfectly straight. And how they do that is they have a microscopic razor that cuts that tape every millimeter while the tape is being produced at 100 meters a second. And they had to invent their own automation controller because the off-the-shelf stuff from Rockwell and some other, like nothing off the shelf could work that fast. So, there's products that's a good story to say. There's products out there that you wouldn't be able to have without automation. I think that's a really powerful statement.
That's actually a really good point. For the longest time, the U.S. had a massive advantage around the rest of the world, and that massive advantage was our precision manufacturing. No one could do manufacturing like we could. And that's less true because, as you mentioned, robotics, stolen IP, and tons of other things have given other people the ability to catch up. Now, there's some things that usually the United States are one of the only countries that can manufacture. What do you see from a technology standpoint that's going to probably even that out? But what if that was our competitive advantage? What's our competitive advantage going forward in manufacturing? or do we lose that and it just becomes you go to the cheapest source of manufacturing because it's cheapest?
So I think there's a lot of intellectual property when it comes down to machine design and how those manufacturing components work, right? Just because the automation layer is there, just because now we have pneumatic cylinders that can have 1 million cycles, right, without being maintained, this kind of stuff, right? It just doesn't mean that any person in the middle of India that's willing to work for 20 cents an hour can create the manufacturing line to make, I don't know, make bottles 50 times as quick or 50 times better than we can in in high cost countries like the States, right? So I think that what's interesting is that really that intellectual property, that knowledge, that innovation component is still locked up here in the US and Europe and many parts of Canada and stuff like that. And you have where they're more or less creating the technology here and then maybe manufacturing it in other countries that are closer to the consumer. It's funny, I met this gentleman from Adidas in a bar in Amsterdam, and it was sort of long story short, I met him in a bar, and he told me that one of Adidas's focuses was to manufacture the shoe closer to the customer, and ultimately 3D print components so that you can have flexibility. So if you're in Berlin, for instance, and you order an online shoe from Adidas, you can customize it, and you literally go down to the store because they're manufacturing it at the store. And that provides customer choice, provides way different interaction with your customer than just shipping something and making something 6 to 12 months in advance and shipping it into a warehouse where people look at it and ship it to them. Like, I want a custom shoe with my signature on it, or I want the tabs to be blue. Okay, go design it. And by the way, they're just manufacturing. So he called it bringing back manufacturing, not because it was the right thing to do or not because it was the fiscal thing to do, because it gave customers choice, and 3D printing is getting to a point where they can do that.
Nice.
So I don't know if I answered your question. Ultimately, I think the goal is not to really, in certain product lines, absolutely to reduce the cost as much as you can, improve the margin, return it to your shareholders. But I think, we're in an age where consumers dictate what they want. And I think choice is driving that. And I think manufacturing costs have went down, qualities went up, but the ability to invent these things that make those things, let's not discount that, right? That knowledge is in America. It's been here forever, and it's only going to get better, right?
So all I heard from that, I'm kidding, I heard everything, but the thing I heard from it was that I'm going to get a sick pair of Fahads here any day, and I'm only going to wear those shoes going forward. That's really awesome. It's going to be like $500 for a pair of Fahads.
So we have smartphones, we have smart houses. What is smart manufacturing?
That's a great question. So my take on we always need something to brand, what we're doing in the industry, right? And smart manufacturing, I'm half in supporting that term and half not, right? Because it infers like we're doing dumb manufacturing, right? It infers that we're actually making stuff and controlling processes in a dumb way for all this time, and all we need is more technology to make it smart. In my career, I've seen systems that were deployed in the 80s. Trust me, one of my first projects was to upgrade US Data Factory Link HMI system to a modern HMI system, and that system was running off a DOS. I forget what version of DOS it was, 5 or 6, one of the last sort of versions of DOS before Windows 95. And that machine, or that control system, controlled the sand recovery system that arguably was in a plant that was 95% automated and was built in the late 80s and early 90s. So was that smart manufacturing? But yeah, they made Duratec cast engine plants that went into race cars and also went into Ford cars, right? And they had great quality, and they had a high level of automation, so that ensured consistency and predictability, and they had, data going into databases and visualization. And this is in the 90s, right? I remember one of the systems we upgraded at Honda was, this is back a couple companies ago when I was part of a industrial startup, that we did analytics. Back then we called it in manufacturing intelligence. Now everyone wants to call it in analytics. But they had a paint shop, and they were collecting data by car type and by color type to determine overspray amounts and this kind of stuff, and into a Lotus 1-2-3 workbook. Now, for listeners that don't know what that is, Lotus was the first spreadsheet, which Microsoft has taken over that with Excel, that whole market. But I mean, that was I had to learn stuff I never learned before, because it wasn't used way before my time. I remember seeing a control system that had a front end of OS2 Warp, that, I don't know, we never replaced it, but who knows if it's still there today. It's 2018, and I bet you it's still there today. So the whole nomenclature that we need to get to smart manufacturing, I think a lot of places have been implementing smart manufacturing ideologies and components for a long time. I think where my view on smart manufacturing is to look at how to make things simpler to troubleshoot, by capturing, essentially more data, making industrial components more natively and easier speak data to not only peer components, like at the automation layer, have a push button send diagnostics as much. You can't really get diagnostics out of a push button, but say there's some additional diagnostics that would be useful, to easily share that with other automation components to make automatic decisions, or to report up to humans to make better decisions, and maybe augment some of that with dashboarding and AI and all this sort of taglines. But I really think smart manufacturing has been going on for a while, and it's a tagline that we use to keep pushing the markets to lower the complexity level, improve the insight, and improve the ability to continuously improve. I guess that's where my
it's probably two components, right? It's the device itself that has intelligence, but then it's also the ecosystem, right? Where devices are talking to each other, as you mentioned. There's some back end, there's a server, everything's communicating from the shop on the floor to the end user. You can deploy service and all that. So there's a bunch of intelligence, and I think to me it just means everything's connected. There's an entire ecosystem around manufacturing. It's not isolated to one thing.
I actually, so for me, because I had time to think about it now, it's really two components. So common automation, we'll say the automation from the early 2000s back to the 80s, was pretty much firmware based. You programmed it to do one thing. It did one thing really well, but it wasn't necessarily an intelligent machine, in any way, right? It doesn't, a human can look at something, assess a situation, and do it. Instead, the robot was just doing what it was told, ones and zeros, running in autonomous mode. And for the most part, that if you tooled your entire line, it would work well, because every robot had a job. Now you're starting to see, quote, AI, right? Some more decisions made at the machine. And then you're seeing, like you said, communications. It's much easier to build a mesh network of machines in a factory. It's much easier to get 4G connection. If Wi-Fi is down, you have fallback. You actually have technology across the spectrum that makes it better. That's one part of it. But as you're collecting millions of data points a second, sending them to a server and collecting them, humans can now get real-time insight into how the machines are acting. Whereas before, you had to observe the machines and say, oh, that's probably an eighth of an inch off. We need to fix that, shut the line down, fix it. And now it's I can see that from a dashboard somewhere and say, that measurement doesn't look exactly right. And potentially, because everything's connected, adjust it from a computer instead of the factory floor. And so maintenance becomes cheaper, success rate goes up, things like that. And I think the interconnection between humans And the automation is what makes smart manufacturing, because it's not like people were doing dumb things before, but it's not like they had all the insights either. So they were satisficing with being professionals, and they've seen millions of cars made in their lifetime, and so they know what it should look like at each step. And when things are off, they can tell. Now it's literally, I have all the data, I know exactly what's happening, and I can adjust from my computer, and life is really good because while I've seen a million cars made, this robot can also test thresholds and tell me, hey, this looks wrong, you should check it and give me alerts. And now, like I said, quality should skyrocket. I don't know if it has or not. I have no metrics behind that, but for sure, that component, that's the biggest component going forward. And I think that's what smart manufacturing means to me.
Yeah, it's interesting. I went through, data and insights, I think is a key part that needs to be unlocked, right? I think, so here's my perspective, is that the technology is definitely making, and like you said, the connectivity is definitely making it easier, right? And I think we're back in even the early 2000s, it would be hundreds of thousands of dollars to get any project worth that level, to get a small sort of analytics project going. Right now, that barrier has been reduced to a lot lower, right? We've been talking about for years at Rockwell, reducing the friction to have insight. The cost of curiosity was too high, so we're going to reduce that down to zero, right? And we're going to do it in a safe manner and secure manner and all this kind of stuff. What's interesting is, like, and although we've seen a ton of pickup in those types of projects, really the same thing, the outputs, what we figured out is that you've got to align to some type of the metrics that you're trying to provide or collect, data in general, have to align with like some action change element, or else it's just data for the sake of data. And back in my past, we were I'll go back to the startup. Our first couple years was, and our whole licensing model was based off of just a number of data points into the database, and we scaled on that. And we encouraged every customer to collect everything in their plant. Digital twin, right? I think we call it digital twin now. Well, the last couple of years of that startup, we said, okay, people are buying the stuff at low value, right? $10,000, $20,000 a pop for, licensed software to do this, but then they aren't renewing their maintenance fees on the software. And we go back to those plants and we say, well, what's the value? And they say, okay, well, we had a project, we solved the problem, we had some visibility, and then no one used it anymore. So we started to put in customer success managers and trying to proliferate people using these tools to drive continuous improvement. And what's the last couple of years, we started to actually make standard training and trained everyone on Lean Six Sigma to consult with the customers to use this as powerful data. Because I think, and what the last part of that story is that we actually went to a level where we totally overhauled our price model to be output driven. So if we're going to improve your productivity by 10% by this engagement, that's the price of the software and the services. And you can't split the software and services, because if you just buy the software, you're not going to get the benefit. So what we found is that you actually had to collect way less data to drive the improvements that people were looking for than previous 5 years prior to that. It was like, hey, just collect everything, just put it all in the database and figure out how to do it after, right? But to your point, I think smart manufacturing in today's world is now it's just easy to collect everything, but we encourage, and I encourage everyone I talk to, say, be smart about it. Translate what you want to do. Say you're trying to reduce the paint variation on this vehicle, or you're trying to reduce the sewage effluent into the lakes. Okay, then translate that back to maybe that only means 5 data points in one report to drive that action differently. I mean, they still have to buy a platform to actually collect the data and report on it, but you almost take it in chunks and solve a problem and then expand on it and solve a problem, rather than some of the initiatives that I've been part of is like, hey, collect everything and figure out how to do it later, right? So.
Well, it's a whole lean cycle, right? You implement, you measure, you learn, you implement, you measure, you learn, you change. And if you're, depending on what you're collecting, if you stop after the first time, well, yeah, you've made an improvement, but almost always every improvement you make hits somewhere else where, oh, we made the paint less of an issue, but now downstream, because paint's less of an issue, maybe the doors don't get put on right? And it could be something silly like that. I mean, it's a contrived example, but at the same time, maybe paint's less of an issue, but you're getting paint in the hinges. And so you always have to be measuring and learning, and how we allow people to see that. And, obviously, you talk about digital experiences, right? The UI, UX, especially when you're working with people that, tend to be undereducated for the job that they're doing. How do we make sure that their digital experience meets them where they're at? I think a lot of software these days don't meet the users where they're at. It tries to pull them in, and it's like, it can't do that. You have to give them stuff they can work with. And so it becomes more and more important as your goal, Rockwell, is to automate as much as you can and have a huge impact on the process. So if you're trying to do that and the users can't use your software, how do they know it's working?
Right. Well, especially if we start talking about things that are not just about getting data out of machines, right? So one of the interesting challenges we have in my team, in my role in the customer experience side, primarily in what we sit in global sales and marketing, is sizing and selection of our products. So this is for engineers, and that might be a seasoned engineer who's been sizing and selecting products for 30 years versus a new grad. And the easier we can make it for that new grad to either interact with a person who's been doing it, because ultimately, so I'll give you some perspectives here. To size and select the drive system for, a roller coaster, okay? Doing that in an online tool with no background knowledge and no implementation knowledge of drive systems, it's impossible. Okay, it's just, you have to know the loads, you have to do the math, you have to do design first, right? And we come in at the end of that design process and say, okay, you need a 1,000 amp service with a spike of this, with these 3 sidecars. Like most of our drives, we've got some standard drives to control fans and pumps and that kind of stuff you can buy off the shelf, but I would say we have a factor of 10 times other part numbers that you literally create on the fly when you configure one of our drive systems, and you get a unique part number sent to you because you need a specific thing for it to do. So it's very complicated. At the end of the day, it's very complicated how to communicate those needs through an online, configurator. We've done it, right? But we also have, day-long and week-long training sessions that engineers pay us to come to our facilities to learn how to size and select a drive from us, right? Because it's just that complex. So we're looking at it and say, how do we make that easier for someone, to find out those capabilities? Because a lot of those capabilities have known through the years, and how that's being known is not digitally. It's through our sales force and our distribution force having relationships with customers. And largely our customers come to us and say, hey, I've been a plant engineer or amusement park engineer for 20 years. I've never had to replace this drive system. And then we consult on how to do that, because our field service people and frontline salespeople are largely engineers as well. So they help them size and select this stuff. And it's through tribal knowledge that you sort of learn, hey, use this thing because you're going to see, you could have a lightning strike, and you need to dissipate the energy somehow. And, at this amusement park down the, competitor down the road, they had this situation where an abrupt stop happened, and we had to have the current be dissipated through this part. So you want this in your system. At the end of the day, our job is to try and make that super easy for people to understand, and that's really hard to do.
Yeah.
But that's an interesting challenge when you think of a different type of challenge than saying, hey, collect information off your plants and use it for better decision making.
So what technology trends are really impacting your automation as a whole, right? As you think about, okay, we're doing this today, but we see, blockchain, AI, whatever, what have you. What do you see impacting the most in the next couple of years?
Well, you touched on it earlier about some of the devices being smarter. Let's just go there before we go into AI and blockchain, those types of technologies. I think the expectations of our people that buy our stuff is to have configuration set up to be easier, not have to dive into a 200 or 300 page manual, even though all the features and functions are there for you to completely tweak and change the way that we try to make generic components that work in a food and beverage plant and a water clarification plant, and it's the same product. You just got 15 different flags you can turn on or turn off depending on your application. I think what I see is the expectations of our implementers are changing to be like, hey, I bought a Nest thermostat and it took me 3 minutes to set it up. And it's connected to the cloud. I wired it into my furnace and my AC unit, and boom, I'm done and they even give me a nice little kit to do it. Well, in the industrial automation space, it's like, here's 50 parts. You've got it. You went to engineering school. Okay. You got a consultant. You need those 3 components to figure out how it works. Well, I think the expectations is here's a part. It's pre-configured for applications and packaging. It's already 90% of the work's done. Just do the last mile and you're good. So I think that has expectations on firmware flexibility, that has communication compatibility, the way we document it. They just want it easier. So I think I'm seeing that trend, and there's multiple levels of technology to do that, right?
So almost seems like, for example, Nest, it hooks up and then has some sensors in it to determine how to configure itself so it doesn't blow up your furnace by accident.
Right.
But it seems like you might be able to do that with some, I mean, not all of it, but hook into like a diagnostic port or hook into someplace that can give you the information you need to configure the device itself based on information it picks up in its environment. Like, hey, it's this hot outside, run in this mode. It's, I'm right. Like, I don't know. It seems like some of it could be done automatically via environmental variables. And then the rest could be, here's an app, click a few buttons, tell us about yourself. And then we've configured it.
And I think it's a balance that we have, because at that persona that we sell to, and they want total control, right? I mean, they're if they wanted an easier sort of off the shelf thing, they wouldn't choose industrial automation to go solve that problem. I think that's where the balance lies, is as soon as you start to do stuff automatically, you've got that, rocket scientist turned automation engineer sitting here saying, but I want to be able to determine what the relative humidity is, because we sell to really smart people, right?
Yeah.
And they want the 50, one of our drives engineers, and I was floored when I started at Rockwell, because I got way more involved with particularly drives and VFDs and motion systems, and they said, well, we have like 700 parameters in our drive. I'm like, well, how many do you think people actually care about? And he's like, probably 20. If you set 20 parameters in our drive, it'll work. Well, why do you have 700? Well, what do you mean why we have 700? Because there's 700 different variables that drive could act accordingly on. It was just like, why are you even asking that question, right? And I bet you there's some people in our industry, and parameter number 694 really matters to, I don't know, warehouser, because they're running a particular application that involves 2 variables being smashed together, and our drive system has to do that. So it's a balance that we'll have. We make it too easy, and your products seem inflexible. Okay, you make it too hard, and then you need a PhD engineer to freaking figure it out, right? So, but to your other question around technology, blockchain, sort of dropping those things, I think where those sort of what I call higher end technologies, I think it's really interesting and where those can go. Let's just talk about AI for a second, right? Sifting through the massive amounts of data and making sense of it, AI is definitely playing now, and it's only going to get more important. On digital experiences, in my group, like for website components, and being able to guide customers and users towards helping them solve a problem, AI is already there, right? It's not a fictional thing. being able to say, hey, I think this person based off their behavior is an engineer or a manager or a C-level person. We're going to start to provoke them on, okay, you've been on our website for 2 minutes. We're going to change call to actions. We're going to move them towards tools that make sense for them, all in the essence of helping them solve a problem, but also in the essence of converting them to a qualified lead for sales to actually do something.
So there's this one of my favorite new buzzwords is edge computing, because it's funny when you really think about it. We've always been computing at the edge. But so what they really mean by that is they're building models and they're doing cool, awesome data analytics and then doing that on the servers where they're really cheap and then pushing them down to commodity devices, automation devices usually. How's Rockwell handling the transition from the traditional either dumb device going to the server, getting an answer, coming back to the making decisions on the device? And how is edge computing being used right now? I'm sure you guys are thinking about it, but are you seeing adoption inside your newer devices?
Yeah, so the provocative statement that I'll say is Rockwell's entire business empire has been built off of edge computing, just in a different context. When we look at the history of, I won't rant for 10 minutes about the history of a programmable logic controller or programmable automation controller. Essentially, these things were created. I'll give you the Cliff Notes versions. Essentially, these things were created to replace relays in plants in the 70s and really found their place in the 80s and 90s. Now these PLCs are, quad core processors that can run a level of scripting that you would and at millisecond and microsecond level response times down to the processes they control. In essence, we're running edge computers. Now these are industrial grade and edge computers. No Arduino here, right? No Raspberry Pis here that could that have to be coded in certain ways because they're running in tire and rubber plants that corrode. A typical computer in a tire and rubber plant would corrode in less than a year. Our controllers last 20, right? That level of compute power in the last 5 years, particularly with Rockwell's Logix platform, has increased tremendously. In addition, like we just released a controller that can run Windows 10 inside of that controller as well, alongside the Logic controller that, of course, we print the ASICs for, and we have the software for, and that actually does the control. It's isolated so that if Windows 10 core is compromised and, from a stability standpoint or security standpoint, it doesn't affect the computation of the logic engines, so that things keep running and people don't die, right? Because like it or not, if our logic engine dies, controlling a big furnace for steel plants, people die, right? So it's a little bit level of difference of complexity and seriousness when you get down to what I call the true edge, right? I think the general market says edge computing is a bunch of data collection nodes inside of plants that collect information, right? And I guess I'm just sensationalizing to say edge computing to us in the automation level is a much different perspective on what you expect out of those types of controllers and intelligent devices per se. So all that being said, do I see the proliferation of big IT organizations trying to push down into the edge? Yeah, we totally see that. And I think Rockwell's got some ton of partnerships in place to enable that, particularly on the Microsoft side with the controller that was running that Windows type stuff to do some really cool stuff. Do I see a level of control being put in those with AI and machine learning and stuff? What's interesting about those type of applications is the unpredictability of, say, an AI engine making a decision that inevitably makes it back to controlling of the process of the machine. I think those technologies will sit above a control layer, because if there isn't structural logic that like a professional engineer stamps that machine as being safe, right, and that stuff is reviewed, And when there's a problem with it, it's updated and restamped like this. That's where I think some of this autonomous decision making with respect to control will never really take hold. It might suggest things that then are reviewed, particularly on the control side, that someone looks at and says, okay, well, if I change my ramp curve on this valve, it's going to break less. All right, I'm going to go in and make that change on my ramp curve. I'm not going to let an AI engine automatically do that for me, because it's really about limitation of liability and really things outside of technology that go into play, right? I don't know if I'm trying to make a point here, is that edge computing will penetrate to a certain level in the edge from a decision making standpoint, but I believe the decision making will always be more of a structured element inside what I would call the true edge, the actual controller and the devices themselves.
So as a final thought, I'd love to get your thoughts on something that I think we can all be passionate about, is that there is a trend, or seems to be a trend, of manufacturing that's coming back to the U.S., but it's really in a different form. It's almost like niche manufacturing. I think you mentioned it, where like Adidas can, manufacture something at the store and then, ship it directly to the consumer. It's almost like farm to table. And you get local food directly to the restaurant, and, manufacturing's going to kind of, it's already following that, and technology's enabling that. So I'd love to get your thoughts on that. And then also anything exciting or anything else that's, you're looking at in the next year or two that might be coming up.
Yeah, I think it's interesting. So talking about manufacturing coming back to the U.S., I think that topic is really all a matter of perception, right? I think in my career, I've had the luxury of working all across the U.S. and seeing different manufacturing facilities, and I think what gets the press are these big, plant shutdowns, and largely it's the, hey, 2,000 people in this plant, they're moving it to Mexico, or they're moving it to a lower cost country in Far East or China or something like that. I think what I've seen, like you said, mid-sized to small manufacturers actually start in the U.S. Let's just be no more about it. I mean, the most innovative minds in the world are here in the U.S. There's a reason why Facebook was invented here in the States, right? There's a reason why I even go back to if you look at some of the innovations of 100 to 200 years ago, right? I mean, I jokingly say, but it's true, that toilet paper wasn't invented until it was invented in the States, right? Mass production toilet paper. My question is, what do we do before that, right? As humans, what do we do before that? And that was only like 1840 or something like that. I looked that up one year for Thanksgiving to tell my kids what I was thankful for, right? So I think that the innovation mindset and the ability for individual entrepreneurs to take an idea and just sort of either manufacture it or create it, that innovation mindset's here, right? You can't really just be born with that. You have to grow up in a culture that America has, right? So I see manufacturing in that sense, it was always here. I guess until you start to scale, that's when you have options to, or you need options to return more to your shareholders, improve margin, improve quality, and go to the places that can scale your manufacturing quickly. Case in point, right? I was talking with a guy from Anheuser-Busch, and he said a large part of their strategy is to keep the percentage of throat, they call it, going down through Anheuser-Busch's pockets, right? So they want to keep 20% or X percent, I forget exactly what percent, of volume going through, America's throats to drink beer or spirits or that kind of stuff in the Anheuser-Busch portfolio. And one of their main value adds as Anheuser-Busch is they've learned how to brew beer in mass over the last 50 years in a highly automated fashion, and beer brewing is all about consistency. One of the stories I have was from them is that Goose Island had to scale their operations so quickly because it became so popular in the Chicagoland area and then nationally that they could not keep up to demand. So Anheuser-Busch bought them, and they scaled their brewing operations like overnight, because it would have taken 20 years for Goose Island's engineers and people to understand the complexities of, I don't know, cleaning in between batches, and the fact that they have to do these 5 steps, because in the 70s, that's what Anheuser-Busch learned. So I think that's sort of an example of manufacturing knowledge and ingenuity here in the U.S. that keeps that type of, I mean, brewing beer, manufacturing, you're still making stuff, right? I think particularly in the US, I think technology is driving us to be able to scale things quicker, so that when we have these new ideas and you become a small manufacturer to a mid-sized manufacturer, you don't have to just run to China and say, mass produce 1 million of these things. We can do that here because of the level of technology we have, and how we're pushing ahead on automation. So I guess that's my warped mind thinking, sort of ad hoc, not really preparing a canned answer for that. A lot of it is focused around the ability to scale, and I think that's how a lot of manufacturing is coming back, or will just proliferate or keep here, right, as we continue to innovate. So
yeah, I think that's great. I think it's a great place to wrap up. It's a good final thought. I really appreciate you coming on. That was a really fascinating discussion.
Thanks for listening. You can always connect with us at skiplist.com.